Hi guys, let's do the multiple strings problem Leetcode 43, and it's kind of a, I would say, a slightly more complicated version of Leetcode 415, I guess, which was add strings. And the idea is that you're doing all this addition or multiplication and all that without converting these strings into numbers or integers just by calling some library function. So we are not supposed to convert them into numbers first and then do the addition or multiplication, but rather we are supposed to be doing this without converting them into integers. So I guess the exercise becomes more of the string handling in your favorite language and seeing some kind of logic in terms of whether you can make if then as while for those kind of decisions in your code. So that is where the problem basically boils down to, I would say, because obviously they're not asking you to see whether you can do a multiply or addition. So anyway, before I go tangential on my discourse, let me just read the problem. The given two non-negative integers num1 and num2 represented as strings return the product of num1 and num2 also represented as a string. And as I already said, is saying do not use any kind of library function to basically convert inputs to integer. And then examples he gives you is num1 is 2 string 2, num2 is string 3, and obviously the output is 6. And similarly for 1 2 3 and 4 5 6, actually string 1 2 3 and string 4 5 6. So let's do this problem and we will use C, because that's where all the fun part is, messing around with the strings. So like what we did in case of add strings, what we do is, first thing we do is we try to find out the length of these strings, or rather point to the last digit of each of them. So that means we would have something known as num1 strlen minus 1, then we have in j equal to strlen num2 minus 1. And so now we are indexing into the last digit of each of our inputs. Now what do we need? We need, in this case, it's not just addition of two strings, so it's actually multiply. And as you know, the multiply is like, let's do a multiply of 1 2 3 and 4 5 6. 1 2 3, let us say you're multiplying 4 5 6 by 1 2 3. What do you get? You get so basically, if you remember your math from your elementary school, you would have what is known as 8. 3 times 6 is 18, and you get a carry of 1, and then 3 times 5 is 15, you get a carry of 1 from the previous time, 16, so that is 6. Again you have a carry of 1, and 3 times 4 is 12, and you had a carry of 1, so you get 13. So basically that is your string, that's going to be number 1. And then you have, let us say, so what would happen is you would have a 0 as the 0 as the for the digit 2, you will start with 0 as the carry, because the tens digit for that is going to be starting from the first, I would say, ones digit will start from 0 for that, because it's a place, its tens digit is actually 1, and this is tens digit was 0. So anyway, you have to start with 0, I think, which you remember already. And 2 times 6 is 12, so that is 2. And then you get 1, carry of 1. So 2 times 5 is 10, plus carry of 1, so 1, you get 1. and now you still have a carry of 1, and then you get a 9. 2 times 4, 8, and the previous carry of 9, so you get this. And then you have one more, which is this time, and now you start with 1. So 1 times 6 is 6, that's easy. Then 1 times 5 is 5, and then 1 times 4 is 4. So this is going to be more like, I should have probably created more space here. So now that way we can align them. So there you go. And now we just have to add these, and that would be a final result. So that is 8 here, right? This is 8, and this is again 8. And so we got, and then you have 6, 3, and 1, and 6. So that is 10. So that is 0. And then you have carry of 1. And 1 and 1 is 2, 9, 11 plus 5 is 16. So that's your 16, and carry of 1, and then you have 5. So that's going to be a final result. So we will follow the same thing. Basically, that's what is going on in the code, but it will all be kind of done in a programmatic way. So let's do that. So now, so what do you expect? What do you think we need to have? We know how to add strings, numbers represented as strings. So that means in this case, instead of adding 2 strings, we'll have to probably add as many of these strings as possible. So we would need a way to store these strings that we will add. So for that, we can have a variable which is result string. Let's just call it result strings. And this result strings will start out as null, and as we get more and more of these result strings, we would be filling up this array. So this is basically an array of strings, and this is C's way of doing it, because it's basically a pointer to this. Anytime you have int star, it can potentially become an array, and now in this case, this is an array of char stars, which is a string. So this is an array of strings. So now we will have a variable known as reslen, which we would use to kind of keep track of this array of strings. And then let's have one more thing. We need to have a variable place 10. I call it 10th place, but I wanted to have 10 first, but apparently it doesn't like 10 in the beginning. So place 10, I'm going to call it 0. Maybe a more suitable name for that this variable could have been 10th place. Maybe, yeah, let's call it 10th place. So equal to 0. So that's good. Now, one other thing we may want to take care of, and I would come to that later, but let's not go right now. Let's start thinking in a way in which we would start to solve this problem. So as you can see, so let's start now. So what's our approach? Our approach is going to be for each digit in num2. So for each digit in num2, how do we say that? While j greater than equal to 0, right? Now we are going to create these strings that we saw, these 13, 16, these intermediate strings. So we would have to have a variable to store those, and we would start out by initializing it to null. Then we would have another variable to keep track of how big of that s is. Then we need a variable to have a carry, obviously, that I can see that you guys can all easily relate to, that we will not to have a carry. And now in strlen, so now we need a variable which is known as I. Okay, here now the thing is this. Every time for each digit in num2, we will have to go over all the digits in num1. So actually, maybe having this I equal to here is probably not even needed, but we'll take a look at that later. Maybe that can be optimized away. or we can basically remove that later. But right now we need a strlen num1 minus 1. And then, so now again we repeat our process, which is saying for each digit in num1. So we would carry over this loop, we'll continue this loop as long as we have digits in num1. So we should call it actually for each digit in num1. And so now let's do that. Okay, so how are we going to do this? We are going to do that by having a variable known as a, which would be num1 I, and we can do the subtraction so that our loop doesn't run forever. So that's our a, and then in b equal to num2, this thing is fixed at this point because we are keeping the digit in what is this trick about dividing it with 0, because that's where actually you're converting ASCII representation of that digit into, or that number into the actual number. So that is a and b, and now in result of this we should say b times a plus carry, right? Now we got our, you could say that we are almost ready to have our first digit or the number, and we need to basically store that. So we need to now do a some kind of memory allocation, which is on S, and we would say that is, I just wanted to make it more clear, so that's why I'm saying size of char. It's not actually needed. Size of char is always 1. So times plus plus len. Now all we need to do is we need to say s len minus 1 equal to and that is your plus. So that's where we have our first digit is stored. So we start building s. Now what do we need to do? We need to make sure that the carry is suitably taken care of. So carry equal to uh, basically that's your, imagine if you added, like for example, multiplied 3 times 8, you got 18 here, result will be 18, and then you basically got your 8 out and your 1 is here in carry. So that's all good, and at the end of it, so once we are done with all the digits for each in num1, then we say if carry is still set. If so, we just cut and paste our boilerplate code here, except that instead of storing the resmod 10, we will actually be storing carry. So that is, let's take this and we can basically take that out. The benefits of cut and paste, but instead of this, you would have to have a carry. Okay, so I think we are done with S was one of the strings out of those intermediate strings, you could say. Now, what is the problem there? As you can see that we are storing them in a, so for example, this 1368, it will actually be stored as 8631. So how do we go back to 1368? We'll have to do a reverse. So it's very easy to write a boilerplate reverse code. We all have done it many times, so just we will implement this function later. So here we have a reverse s. Now what is the issue before we go back to our this outer while loop? We have to appreciate that this might be true for the first resultant string, but the next time around we will have to have a 0 at the 10th place. We have to keep adding these zeros. So next thing we need to do is we have to have for each 10th place value we have to add a 0. So k less than, we can say 10th place, k plus plus, okay. So again we are going to keep adding more stuff to our resultant string depending upon the 10th place. And what we need to do is, we are not done yet by the way, we have to have s, we do actually have to store that 0. So far we have only allocated the place for it. So that's where your 0 has come. Now before we move on, we have to make sure that the 10th place is actually incremented so that the next time around it has the correct value. Now we are almost done with creating our string, generic intermediate string, but there is a problem. We haven't null terminated it, and that can be done very easily by sticking in a null character, and then we would be done. So that is pretty much, you could say, there you go. So that's where your one of the intermediate strings is done. Now how do we go about storing this in the result strings? That can be done very easily. We already know the tricks now, how to keep doing this realogs, and right. So that is your, now this time we do have to have a size of char star, and makes sense because that's not 1 byte. It could be 4 byte pointer, it could be 8 byte pointer depending upon your machine. So times plus plus res len. So here we have res len. Okay, so now all we need to do is basically stick that s into here. There you go. And then we do a j minus minus because we do want to come out of our outer while loop. So let's see if that seems to make sense. So let us see. So we started with j, while j greater than equal to 0 should have been, I would suppose, because otherwise you will miss one of the digits. So this is looking good, but what is the problem? We have all these result strings, but we need to actually add them to actually have our real multiplication result. So then we would suppose that we can write a function which is add a string and which returns a char star, which is the final result. So result is strings, and then res len is the length of our array of strings. So I think that's what we need to do. But what is remaining? First thing I can see, we have to implement our boilerplate reverse function. This is very easy. But what is not easy is going to be how to add these strings. So let's implement the boilerplate reverse function, and that's for our us C programmers is a kind of a, after having done it quite many times, it becomes very kind of, it comes naturally to you. So basically it's a very well-known trick. You start by pointing to the in the beginning. You have two indices, one is pointing to the beginning, one is pointing to the end, and then all you're doing is going in a for loop, which is initialization is already done. You basically increment one and decrement the other until they meet in the middle, and you're basically pretty much done. Okay, si equal to sj, and then sj equal to si, sorry, temp. That's your reverse function, but we have to implement our big function here, which is add strings. And how do we go about implementing that is going to be the real challenging thing now left in this program. So as we know, when we did add strings for two strings num1 and num2, in this case we have to kind of have a generalization of that function and be able to add strings which are more than one. For example, in this case there were three intermediate strings. So okay, so how do we do that? So let's implement that. So this function signature is going to be, it will return a char star, which is the result of the multiplication, and it would take a array of strings. So that's here. Okay, so it will take array of strings. Now we can have a variable on the stack which we would, okay, let's call this outlen, which is the output length of this s that we would be returning. We need a carry, obviously, because we are adding things here, we are adding digits which might result in a carry. Now let's have it, because this time we don't have a very easy way to saying, hey, strlen on num1 and num2, because you can have any number of nums here. So then we need a array, and we need actually an array of length of the string, so which is going to be dynamically allocated. So which is, let's do an allocation right here, and this is size of int, because we need 4 bytes, and then len, and then the len was the len that you got passed in as an argument for this array of strings. So because as many as many strings as there are in res is as that many elements we need in our lengths array for the length of each of those strings. Okay, so let's assign the values to this by going over our input array, and all right, so now we have okay, so here we are. So that's where we will get the, you could say that instead of strlen storing, is actually storing the last index of that is string. So that's the idea here. Because we would, when we start adding from that digit onward. So now the last digit, yeah, because you know, if you have res is strlen of one of the strings is 6, then the indices go from 0 to 5. So that's why you need the len I as the pointing to the last digit in that string. Now you see what is the next thing we can do. We need to do our actual addition here, and that for that, as long as we have any uh, only time we stop addition is when the lengths array have all negative values. As long as we have digits to add, we continue to add. So we would need a something like this, while something like, let's say, while not check all negative values, and right, we continue to go. We will implement this function later, but right now we are saying, hey, it's like what we had in case of two, when we had only two strings to add. We used to do something like this. We remember we did something like while I greater than equal to 0. Imagine I and j was were the lengths of this string, or we used to say or j greater than equal to 0. Please go and take a look at the problem 415, which I think I did last time, which is add strings. You see that how we used to do that? Now we are kind of generalizing it because we don't have the luxury of only dealing with two. We may have to add as many strings as are given to us. So that's why we are saying while not check all negative values. So as long as these are there is a one positive value somewhere, that means we have work to do. And now we would have a generalization of the earlier case again, where say, and then here we would say for loop, and then this is where you basically accumulate you're doing one of these. So basically this is like, think in your mind that we are doing one of these, like 800 or maybe 613 with the carry added and things like that. So here we say sum equal to sum plus, I mean this of course we being very smart C language programmers, we can do something like this, sum plus equal to, right? And then what we do is this, we say if length I is greater than equal to 0, because see, if that particular place in the string is already finished, I mean it doesn't even have that particular place in the string, we do not have to worry about adding that one, right? So we have to skip that one. In that case, we can simply add 0. How do we do that? We say greater than equal to 0. We use C's this operator that you guys have all heard of. And so this is again res I, and now we are actually taking one of those strings. So here now think about it, that we have length I and then minus minus here, and minus we basically get the digit because we need the digit to add. So this would be a result if there's anything there, otherwise we just return 0. When we come out of this for loop, we are in amazing shape. Only thing need to do for us is to add the carry. Now we have our final sum, and we would do the actual work of getting the digits that we need, and that would be let's do a reloc on S because we need the space to store this digit, and then we would say to now sum mod 10, that gives us the actual digit to store, plus 0 to basically convert that into ASCII, and that is stored, and the carry is basically this, and this is your integer division. Never forget that. What does integer division do? So if you have something like 15 by 10, what do you get? You get 1, not 1.5. Integer division discards the decimal and anything after that. So that is your, I would say, pretty much your your actual digit is stored. Now once we are done with adding the all the digits in all the strings, what is left over? So imagine we have a leftover carry, so we'll have to store that one as well, right? So that is here reloc, And then here we have again, this is a very standard trick, we have been doing it for a long time now, I would say. And just store the carry digit. Okay, this could also have been done as carry plus 0, but I'm thinking carry is always 1. So we might as well just do this instead of doing something like carry plus this. In any case, so I guess both of them should be all right. Now, only thing remaining for us to do is do a reverse on this. And luckily, our reverse function that we wrote before is going to be useful. And here we are. And now, before we say that we have achieved our goal, we'll have to stick in a null character in the grand old style of C programming language, because without that the string is not actually complete. A string is only complete if it is null terminated. That's the definition of a C string. If you don't know that, you're probably at the wrong place right now. So then we just return S. Now, do you think that's all we need to do? Our work is done. Can we start jumping like code monkeys? No, you cannot. So we'll have to do things like what is remaining here. I can see one thing, which is we haven't implemented this. It shouldn't be a big deal, but the program will not compile without that. So let's do that. And we would not use a bool or anything. We will simply use the C's convention of anything that is 1 or anything that is non-zero is true and 0 is false. So we say int check all negative values, and this is a very standard trick. Anytime you want to pass an array to a function in C, you also have to pass its length, because it's the function, the called function doesn't know how big your array is. Now let's start with, this is a very easy stuff I would say to do. Start with a flag like all negative values equal to 1. So let's assume that the array doesn't have any positive values or 0 or positive values. All the values are negative. Let's start with that flag. And then what we would do is we'll walk the array, and when we see that and this condition is not satisfied, we would just break out and return false. So all we need to do is have a check saying if AI is greater than or equal to 0, then we know that we can set all negative values to 0, false, and then we can break out. We don't need to go any further. And so basically all we need to do in the end of the function, before the end of the function, is just return this flag. All negative values, return all negative values. There you go. So with that, let's see if our program at least compiles, and we haven't messed anything up. And it was kind of a little big program, but that should not be a big problem. Let's try it. Okay, so he's saying there's a problem here, and the problem he said is there's no n. I can see that. Okay. Alright, multiply is saying you have a problem in 94. Let's see what we did wrong at line 94. He's saying you have tens place expected, he's saying is expected a, did we use the correct variable here? Tens place looks good, I don't see a problem. Now for int, okay, I see there's a problem here, int k equal to 0, that was easy. Okay, now he's saying we have a problem. We have, I think, okay, that was easy as well. So far we've been getting lucky. We're only hitting into typos. Okay, that was easy as well. In C, you see the Python, what happens when you've been doing programming language like Python, you tend to start like forgetting your statement termination semicolon. So, wow, so that's absolutely amazing that it actually worked fine. So, I guess let's take some simple test cases that he has given us. So that is, let's say 4, 5, 6. Cool. So that's working absolutely great. Now, what do we need to do? Suppose let's take some more simple cases, very simple cases. One that he had first time around, 2 and 3. So 2 and 3. Let's see what happens now. Alright, so that works as well. So we'll try to do a submit and see if it passes all the test cases. If we get lucky, we are done and we can celebrate our victory today. Okay, so there is a issue. It's saying address sanitizer, segmentation violation on non-address. Last executed code was 1, 2, 3, and 4, 5, 6. What is the problem here? Have we messed something up? Let's see. Why is this a problem? When we just saw this 1, 2, 3, 4, 5, 6 when we gave here, it was working fine, right? So let's do it here. 1, 2, 3, 4, 5, 6. It was working fine. I wonder what happened when it went as part of the complete test case. So in any case, so one other problem, let's try to submit again. I wonder why that failed over there. It is working fine here. Segmentation violation on address sanitizer, deadly signal. Have we messed something up? What do you guys think? I was thinking everything is working fine, but apparently that is not the case. What about, imagine we give something like this, 1, 2, 3 multiplied by 0. I think, let's see if that works. So we have a wrong answer and we can see why, because even though the output is actually correct, but you see he doesn't expect you to write so many zeros when you can write only one. And that probably we can take care by putting a case like why are we going through all this big hump of code when uh, we can simply do what is known as what we should do is say if we should do a string comparison if any of these num1 or num2 is 0. So if strcmp num1 is as is basically 0, then or compare or a string basically this is C's way of saying is num2 0, or right, having done that we say return 0. Alright, so that should take care of this particular case, I would say. Okay, so that is accepted as well. Now, only thing we need to see is that why we are getting a address sanitizer issue over here. In one thing I can see is there was no need of this here in I equal to this. Maybe we should try to get rid of, even though I know that's not going to be this problem. But since anyway we are doing this I here, maybe we may have to declare it here also. So let's see. Okay. and 1 2 3 4 5 6. We still have that problem, but if you give the same test case here, it's fine. How is it possible? I have absolutely no idea what's going on. This is some vagary of the. Okay, so I suppose that cannot be an issue. So check all negative values. Did we screw something up? Let's go through the whole code again. We see that reverse is working fine. I plus plus j minus minus, that should be okay. Check all negative values. This looks good as well. And return all negative. Okay, so that looks good as well. Now let's say add strings. Did we mess something up here? So length equal to malloc size of int. That's okay. Size of int times len, and I less than len I plus plus lens I equal to strlen res I minus 1. That sounds good as well. Now while this while not check all negative values. You see any issues here? I don't see any issues here. Okay. For int I equal to 0, I less than len I plus plus sum plus equal to lens I greater than equal to 0 question mark res I lens I minus 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 0. Okay, or just 0. Sum equal to sum plus carry. Okay, sum mod 10 plus 0. Okay, carry equal to sum by 10. Okay, now if carry, then we say s equal to real log s plus plus outline, and s outline minus 1 equal to 1. Looking pretty good. And then we did a reverse on s outline. Okay, and then we said s real log s, so basically we stick in a null character. So that is looking good as well. S outline minus 1. Okay, now let's say we mess something up in multiply. So we said j equal to num2 minus 1, result string is equal to null, and then we said tens place we initialized to. Okay, so we haven't initialized this res len. Maybe that could have been an issue. I see what was going on. I think that was the problem, because you see, if you don't, then what would have happened? Let me ask you one question here. This plus plus res len, oh my god, that was a real problem. I see your point. Okay, I think now it should work. There you go. So there we have our glorified success, and we can heave a sigh of relief at this beautiful problem of multiplying two strings, which are actually numbers represented as strings, and it basically works. So as you saw that these little bit of problems could be these little issues can come to basically bite. As we saw that we wasted like a couple of minutes in figuring out why we were getting a problem here when we do a submit, but it was passing for some weird reason. It was passing if we run code like for individual test cases. But you see, if reslen is not initialized, what would happen? When is the first time the reslen used? Reslen was used here. Imagine you are basically doing real log, but instead of you have a wrong restlen value. Basically, that's what would happen. And so you don't know how big of the array of strings is, and the memory issues here, and it was really a problem. And most likely, imagine your restlen is even like you don't know what value it is. You might have accessed some memory somewhere and result is string, and that's why we were having an issue. In any case, long story short, it's working fine now, and it was in retrospect, I would say it was kind of a little bit more involved than I thought, because but it's a very good exercise if you want to play with the strings in C and memory allocations and things like that, because ultimately think about it, you just this is the generalization of the add strings 415, where instead of adding you're multiplying, and for that now you'll have bunch of those intermediate strings that you have to add, so you can use previous knowledge. And so you have a helper function add strings here, which calls to other helper functions to check all negative values, so you get to also play with arrays and see how are things how to basically return something when some value in an array is not to your liking. So it's all looking good. I wish you guys all the best, and I hope to see you in the next interesting problem that we would solve. So do not forget to subscribe to the channel. I know it sounds like a very cliche nowadays. Whichever program I see, people say, "Hey, subscribe to my channel." Well, I leave it to you. If you find it's useful, please feel free to subscribe. And I wish you all the best in your coding journey and in interview appearances. And until next time, adios, hasta mañana.